Hello, everybody. Welcome to the LeetCode Contest Corner. This is my very first episode doing this. Kind of a new idea. Um, so for those of you who don't know me, and um, that's probably all of you, um, uh, I am I am going. I'm in college right now. I am going into a computer science major at my college. I am. I just finished a semester of like the at the 200 level of one of the computer classes, computer programming classes. Um, and so I just started summer break. Um, I need a summer break, man. My brain is just I can't do more school right now. But in order to um my keep it alive, keep my brain going, chugging along, I decided I should do these Leak Code weekly contests. I just came across this website. I think I kind of knew about Leak Code in the back of my head, but um yeah, so I'm a pretty I'm still pretty amateur at coding. Um uh I still do things which I think, oh, there's probably a better way to do this, but that's how I do it. I'm still learning, and I'm hoping, at doing these weekly contests, uh, I'll I'll get better. And so I decided to make these videos to kind of catalog my journey, and then yeah, maybe there's something you can learn too. I don't know. That'd be cool. That'd be rad. I don't know, but so if you're watching, tell me why you're watching. I don't know why you're watching. It's a little weird, but hey, I'll do my best to make it interesting. I'll go through my basically, I'm just going to go through my thought process for what I did uh during for what my program was, my programs. Um and yeah, so it's a little weird. We'll get into that in a minute. So, uh okay. So this was the weekly contest 344. Um So yeah, so just to be clear okay, for the future, I think for over the summer is May right now. That's when my college think summer starts. From like May to end of August, I'll do the weekly contest. I probably might even try. There's bi-weekly contests too. I'll probably do those. We'll see. Um, so I'll do these, and after I finish, I'll post one of these videos. Um, I don't know when. I should try to get them done before I get too lazy and push them off. So hopefully it'll be Sunday or Monday that the videos come out. Well, who knows? By the end of summer, I'll be posting them on Saturday before I start the very next contest. Um, but we'll see, I guess. Okay. So, anyways, this was weekly contest 344. Um, And so for you, those of you who don't know, what they do is they have four problems. I think it's four. This is my first one, so there might be difference. And you get a score for each one. Uh, Different score for each one. The harder the question, I'm guessing, the bigger the score. And you want to try and get them all done. As you can see, with this is the only green one. This is the only one I got done. Um, the easiest one. I don't know. I might have been able to do the other ones, but the problem was the first one took me the entire hour and a half we were given. So yeah, that is what happened. So just quick shout out. Hopefully, I don't know how cheater proof this website is. Like I literally just came across it, man. I'm not that knowledgeable in this community at all. So hopefully there aren't a lot of cheaters, but I'm assuming you're not. John K. Ram, John Cram. Good job on winning. Uh, maybe one day that'll be me. Not anytime soon. Obviously, it took him 9 minutes and 36 seconds to do all four of the problems. That's insane. I don't even know how one does that. But I'll go through my solution, go through how I did it, and then maybe we'll look at the other ones. Maybe I'll give you my first thoughts. Um, or and show how stupid I am at, because even like understanding the questions takes that's is like it's a lot to think about. Um, so okay, here we go. We're gonna look at my code. Ooh, please don't make fun of me. Okay, I use Eclipse. I don't know if that's good or bad. Um, so yeah, he okay. So also while I'm here, I if anybody is watching, one thing you might notice is probably useful. I have okay, so I have a package, um, and then it contains my code because I don't know how to do it any other way. I have to create a package. Like, is there a way? Because I feel like, I don't know. Because I feel like before, like when I first started, I didn't need to create a package. But then one day it broke, and I didn't know how to create a it wouldn't let me run my code and I was so confused, so I just figured out a way. Okay, I create a package and then I put all my code in that, and then each time I have to declare, hey, it's in this package. So if any you know an easier way to do this, it's probably fine the way I do it because it's like, oh, it's technically more organized if you got a lot of code, but it's kind of unnecessary when you only got one piece of code. But that's how I do it. Um, Anyways, getting into the actual code. This is my test, like just the main method, just to so what so okay. All right, right. So forgot, I'm going a bit too fast. Let's go into the question. Um so find the distinct difference array. This is going to be a lot. I'll read this out and I'll try to explain it afterwards. Um Yeah, so okay, so you are given a zero index array of nums length n. Now, if that doesn't make sense to you, I try to explain it. I'll do it afterwards. Okay, so let me just read the rest. The distinct difference array of nums is an array diff of length n such that diff I is equal to the number of distinct elements in the suffix nums, you know, all the nums subtracted from the number of distinct elements in the prefix nums and the prefix nums. All the all right. Okay, so this is the suffix of nums. This is the prefix of nums. Okay. Return the distinct difference of array of nums. Note that nums I to j denote the subarray of nums starting at index I, ending at index j, inclusively, particularly if I is greater than j, then nums I j denotes an empty subarray. Now, I'm going to be honest, I don't know what this is talking about. I don't know what this last line. So if you came to this video just because you want to know this last line, I'm sorry. I don't know exactly. I might figure it out. Like I'm trying my best here, guys. Okay. So, all right, but I learned a new term today. All right, starting at this first line, you've given a zero index array. What is zero index array? What is that? In zero index, it's just an index as far as it starts at index zero, so it's not an array list or anything like that, I guess is what it's saying. So it's just an array. That okay. Uh, it's a little weird that you would point that out because, like, oh, I just want to make sure it's not an array list. Well, then you just say array. Don't say array list. I don't know. So we got a num with lengths n. So yeah, nums it's can be any length, and okay, so the distinct difference array of nums. Okay, so this is the okay. So we're trying to the distinct difference array. That's what we're trying to find. So let me just go down here. This is the output. This is the distinct difference array. Now, each of these each of these members, what you call it, elements, each of these elements are is the distinct difference that we're looking for, okay? So the best, okay, this is the best I can explain to you. So for index 2 of the distinct difference array, it corresponds to the prefix in the first array. Now, what was that? The prefix up to 1. This is because this is index 1. Sorry, I don't know if I said that right. So in index 1 corresponds to index the prefix of index 1 in the nums array. Now, what does that mean? Ooh, boy. Okay, so that means that this is okay. That blue bar, that's where we're cutting the array in half. The first part of the array is the prefix. The second part of the array is the suffix. Now we need to find the distinct difference. What does that mean? It means we need all the elements in the prefix that are distinct. That means only count each number once. So in this first part, we got 1 and 2. Those are both distinct, so we have two elements. And then we need to find, so remember, 2 for this for the prefix. Then we need to find the number of distinct elements in the suffix. That so this side, and there's 3, 4, and 5. That's 3 distinct elements. So then the difference would be the prefix minus the suffix, the distinct. So that's 2 minus 3, and that gives us -1. So the for index 1 here is -1 as a result. So think of it, okay, so the index 1, think of putting this line splitter, the cutting the array right after the index. So then, okay, going back to the first one, index 0, we got 1 minus 4 on this side, obviously. So that gives us -3. And then go on, okay, for index 2, we got 3 minus 2, which is 1. Index 3 is 4 minus 1, which is 3. And then index 4, which is 5 minus 0, which is 5. So yeah, so that's that. And then, okay, going down this one where it's repeating some. So we let's go here. We'll start at index 1. So we got two distinct over here. Um, minus, okay, these are all distinct. So -3. So that should still be 2 minus, yeah, 2 minus 3. That's -1. Okay, so I still understand it so far, right? So then let's go index 3 gives us 0. So right here. So there's only two. There's only two. See, there's 2 3s, but we only count them once. So it's 2 minus 2 gives us 0. Okay. Now, maybe I'm completely wrong, but I'm 90% sure that is it's asking from us. Okay. So now back to the code. Now is when I should go on the code. So this is the the main method. Just so I just create a list. This is me testing it with a bunch of stuff, and then this is so yeah. So I have the list here with the array, the test stuff, and then I don't care about this stuff anymore. So I put the list into the method to change it, and then I just put it back into the list because I don't care about this old stuff, and then I just print out the list. Um, yeah. So that's just what I'm doing up here. Basically, I'm just displaying the distinct difference array based off of this list. Okay, that's simple. All right. Whew. Okay, so we get to the distinct difference array. this is where it gets crazy. So again, and this is, I trying to do this fast. It's not optimized. I don't optimize my code a lot. Come to think of it, I haven't really been asked to yet. It's just basic, like, oh, figure out how to do this. Worry about being optimized later, I guess, future classes. Anyways, so okay, then all right. So we get the parameter nums is coming in. We'll get that from the input. So num, whenever you see nums, that's this boy, and the length related to it and such. Excuse me. Um, so that's that, and we're gonna return the list, obviously, in an array. So okay, so then let's just go line by line. We start with list. I create a list. This is going to be the result. We're going to put the result into list and we're going to display it. Simple as that. Honestly, we just create up here because we can't have it in this for loop because that would not be good. So yeah, we have the list that's ready for later. Okay, so then where you're gonna it's gonna be a lot of thinking. It blew my brain up a few times while I was doing this. We start a for loop um, of nums. So this is gonna go through the nums array. This is I0 up to the nums dot length. This is going through the nums array. Okay, that's what I is. Let's keep track of I. I'm gonna keep. It's gonna be hard for me too. All right. We get to all right. So then, okay, then I created this. Holy cow! I created this by. It's just funny. This is the funny part. I created this like thinking I had to do this, but in the end, it just became a way to make it easier. And then, holy cow, it made it easier. I created a prefix list. So this list, what this does, it just holds the prefix. Let's get this boy over here. It is just gonna hold like the first part, like so. This is the array. It's just gonna hold the first part. That's it. Uh, that so to do that, okay. So right. Okay. So if we're splitting it, um, so the prefix list. Say we're on I index of one. Sorry, so that I would be one. The length would have to be two because there's two items in that. So that's why it's I plus one. So that's getting the index. That's the length of prefix list. Okay. Then for this for loop, don't ask me why I made it X. Usually I go to J, but this was a special for loop, I guess. So it had to be X. Obviously, because like obviously first I do I, but then it has to be J. But okay, I made this X. So this simply takes takes X, or yeah, it takes the index 0, which would be this one, and puts it into the prefix list. Now, for now, X, the index of prefix list and nums is the same because they're both starting from the start, and going about halfway through. Now that's fine for this one, but it'll be different for the suffix list later on. So keep that in mind. Um, So we go on. So yeah, so that creates the prefix list. It goes through, it goes up to the I plus one, adds it, same thing. So yeah, I plus one because you hopefully you know how for loops work. You want to go is less than, so I plus one will be two. That means it'll only go up to one for the index. So yeah, go up to it'll put that boy. By the way, part of okay, I'm gonna describe this, and there's kind of an error in this, I think. So coming up. Not so far. So far, it works fine. But there's going to be an error with the counting. Just getting into this distinct prefix. There's going to be an error that I fix later on. Kind of. So if you guys can see what I did wrong, let me know. If you can't, I forgive you. It's fine because I don't know what I did wrong. Maybe I will figure out as I'm doing this. I kind of doubt it though. Okay, so we got that. So then I create a linked list. Now, do this, you gotta do the import Java util freaking linked list. If you don't know what this is, it's just think of it. It's just a list, like it's just a list. It just holds on. It's like an array, but it's a little easier to do, um, to use. It just holds all the numbers. I call it p done, which stands for prefix done. I'm done with these numbers, basically, is what I'm saying. And then, so that, keep that in mind. That's what that is. And then distinct prefix, that's counting how many distinct elements we have so far. So we start at 0. Okay. So now we go to the for loop J. That's where we get J. That's where we're starting to use J. Um, so then, so we, yeah, we go, so we're going through the prefix list. This is where it's easier. We're just dealing with the prefix list. That makes life easier. So we're going through it. So if, so then the first thing it checks, so we're starting as index 0. If the p done, the linked list contains um, prefix list J. So that's the current one we're on. So, so if it contains this number of the current number we're looking at, um, then it will just skip. It'll continue. It'll restart the for loop on the next iteration. So that means we already the number already exists, and we don't want to count it again. We've already counted this specific element. Otherwise, it doesn't. We haven't seen the number before, so we increase the distinct prefix by 1, and then we add the number to the linked list, um, and then we keep going. So basically, let's go. Let's see. Wrong. There we go. Okay. So we start we're counting the prefix links. Okay, the first one is 1. Oh, and then okay, this is p done, d for done. Um, so we got 1. Is that in done? No. Okay, so sorry. Then we increase the distinct prefix by 1. Let's keep it back here actually. And so then we add 1 to the done. Then we're on 2. Is 1 in the done? No, it's not. So we increase this to 2 and we add 2 to the done. Okay? That simple? Little bit? You getting it? I hope. Um, I'm no teacher, so I'm sorry. I'm learning computer stuff. I'm not learning teaching. I'm doing my best though. Trying. Hopefully you understand. That's what's going on here. So this is the heart. This is the heart and soul of the whole operation, man. This is the heart and soul. This is counting the distinct. This is the hard part. Okay, so then, right. So then it's the same thing just with the suffix. Okay, so then, okay, I'll just try to say the differences. So the difference for the suffix, the length is going to be, so we get the end of the nums array, the length, and we'll subtract it by I, the amount um, we are in so far. So we're saying, so it's got array length of 5, and I is 1. Is it? not 2. I guess, yeah. So 5, 4. Right. So 4. Right. Right. That's the length. So, right. Because, see, we have 3 items in here. Thinking, hmm, this doesn't seem right away. Maybe this is where minus I. Hmm. So, okay, because let's say it's here. It would be, I would be 2. And 5, 4, 3. It's one bigger, which is good, right? But, hmm, it's not given the length though. I guess, okay. This might be, this might be where the issue is coming in, I bet. This is minus I. So what if we do a little, now I'm just testing this. So basically what this is trying to do is like get everything after the I is what it's saying, right? Um, so we'll leave this in. We'll see if this fixated or not. Let's hold on. 2. Sorry. 3, 4, and 5. Yeah, 1, 2, 3, 4, 5. Okay, that's just for later. All right, back here. So this gets to the second half. And yeah, then we got suffix. And so this is where we have, so that we start x at the middle part at I plus 1. So we start at, so yeah, so index is 1, so it'd be 2. So we start at 3. So then we add, so this will be, it'll add 3, 4, and 5. But then here, uh we made this x again because I'm silly. So then x will be x minus I, um plus 1. Is this connected, I wonder? um so that will subtract, right? Because we want it to be 0 at the start. So it should be, so we're get right because we got x plus 1 here. So we're just getting rid of that x plus 1 because we want that to be 0. So we just, whatever this is, we're getting rid of it so it can start at 0. That's what we're doing. Okay. See, who doing my best, and like this shows you how this was a tough one for me. Then we create the same thing. S done. The numbers were done with distinct suffix. Um, and then we see if did we count it already? If we did, keep going. If we didn't, add it. There's another one. And then at the end, this is the difference part. And okay, this is the difference part. It's the prefix minus the suffix, and that should just give you the answer. However, I kept getting like after I came up with this solution, I still kept getting exactly one less than what the answer should be. It was always perfectly exact, except it was one less than the answer should be. So I did a little, gave it a little +1 boy right there. Pat him on the head. He's a nice little boy. Adding 1, and all the answers came up true, and all the tests came up true. Turn list, and bam, that simple. Now, I will this fix it? Let's find out. Uh, okay, let's run it. It might break. Hey, it didn't break. Let's go here. Um, so now it should be 1 greater than what it should be because the +1 is still here. So 3, that's good. 1 should be 2. 3 should be 4. Well, there we go. We found the answer, I think. I'm pretty sure. So we just get rid of this little dude right there. Then, let's try this one, is what I want to do. If this one works, it probably works for all cases, as far as I know. So let's see. And is that the same? -2, -1, 0, 2, 3. There we go. Okay, so is this guy. Um, so this is all right. So now I'll explain my thought process here. I don't know if I did it well last time. I don't know what I'm talking about, honestly, man. So this is because I don't really. Okay, so this is num.length minus I, which as we can as I write. So for us here is I is 1. Um, so it's minus. We want it. Okay, see, this is the issue. We want to subtract the length of this minus the length of this. We don't want to subtract the index, but a good way of doing that is just getting the index and then getting rid of another 1. Because, yeah, because the index will be 1. So we just increase it to 2. That counts everything. Increase it. And by increase it, yeah, so by making this number bigger, making the number bigger, we're subtracting a negative, you know, making a negative bigger. You get what I mean? Yeah. So we're subtracting 1 to make it bigger. So right, it's like saying, okay, so we want, so the I is the index, but we want the length, so we want geez, we want it to be I plus 1. So it's subtracting I plus 1. And then if you know your yeah, so let's just leave it like that. But the way I had it earlier, if you know your multiplication rules, you can, is basically saying -1 times I plus 1, so you can multiply it -1 to both. And so it'd be the same thing if you did minus I minus 1. So, and then so there we go. That's where +1 came from. That's where we're missing it. Although I don't really get how. I don't get how it makes sense that it would break it somehow for sure. It's nice that it broke it in a nice simple way that I could just add 1 at the end and still get the points. It's really cool. I was able to finish the thing. I don't know if I would have caught that in time. Uh, but yeah, so just keep that in mind. Cause like before, so it was. Oh, okay. I see. Okay, I'm seeing what happened. So it would be starting. Yeah, this really could have created. Actually, ooh boy, it really could have. I don't know. It was adding. So this had an extra number. That number, it might have even. So by doing that, we had an extra number. Now, where the extra number came from, it probably is what I'm guessing came from the prefix. And because of that, this was always had 1 bigger than it should have, so it made it 1 smaller than it should have. So then by adding 1, um, it would always it would fix it. Get what I'm saying? It's the list was bigger, so we just wanted to subtract these elements from these elements, but instead of doing that, we subtracted these elements from these elements. We subtracted 1 and 2. We subtracted 2, 3, 4, 5 from 1 and 2. We did 2 again, is what I'm assuming what happened. Yeah, because, yeah, that checks out. Or, but see, then I think, because I still had I had I plus 1 here, so, a needle pulling thread. So, it probably was a 0 or a null. A null would have broken things, I think. Um, maybe not. If okay, so if all bloody genius, hmm, if it contains right, okay, it probably was null, but linked list, I guess it said I don't have so it had this had a list of numbers, like 4 3 2, just random numbers. It had these numbers, and then I'm like, hey, coming down here on the like last number on the thing, do you have null? And it's like, no, I don't have null. So it's like okay, so it doesn't contain it, so it skips that. And then it's just like it increases its distinct suffix and then adds uh null to the list. It's just okay, null. That's a number, kinda. If we tried to add or subtract with that number, there would have been problems. But just asking the linked list to hold on to the numbers, no problems there. So it had null. I'm pretty sure it was just null. So yeah, um, right, nums dot length. Hmm. Right, because we didn't right. So right, it was just a okay, just a blank spot in an array. Okay. So that all right. So that there we go. We fixed it. Wow, you guys are the best helping me fix it. I genuinely, when I was up here, I was like, I don't think we're gonna do it. I genuinely didn't think we were gonna do it, but there it was, right there. Whew. Those little things will get you. They'll get you. So that was my first LeetCode contest. Um, I hope if any of you are still watching right now, um, if any of you are watching right now, say pretty butterfly in the comments, and everyone's gonna wonder what you're talking about, but we'll know. You and I will know, and I'll see that comment, and I'll be like, you're a real one. You are a real one. All right. So that that was week 344 for the coding contest. I guess okay, so that's what I did. So yeah, that's the amount of logic and junk needed for that code. How someone does that in 9 minutes? Not, no, not even just that. They did that plus three other problems in 9 minutes is beyond me. I'm kind of like proud that I was able to even do that in an hour and 30. Holy cannoli. So that was my code. So look, let's so let's look at these other ones. I for a moment I thought about what if I just skip this one and maybe try another one. Maybe they'll be easier or more up my alley. Um, give me a second, guys. Sorry, need some water. So, anyways, but looking at this one and another one, I was like, nah, let's just try and finish my boy. I did it. Okay, I just noticed this difficulty medium. What did the other ones say? Uh, oh no! Ooh, this one was easy. Oh, this is gonna be a long summer. What about those? So that's medium. This one's medium, and then this one is also medium. Okay, so let's just look at them. I'm gonna look at them, see if I can even understand what it's asking. Okay, design a data structure that keeps track of the values in it and answers some queries regarding their frequencies. That's not bad. That, so far, I understand that. Implement the, ooh, interesting. They're adding implement the frequency tracker class, I assume we're creating the class. Oh, okay. So this is the presets they give you. Um, so public frequency tracker add. So we're filling all this stuff in. I assume this is the constructor, the default constructor. Delete one has frequency. Okay. Initial with an empty array initially. So okay, so we add so then add the add method adds number to the data structure. Number, what's number? What is number? So, oh, it adds a number. Okay. Adds okay to the array. So we got an array with numbers in it. Okay, okay. Delete. Deletes one occurrence of the number from the data structure. The data structure may not contain number, and in this case, nothing's deleted. Okay, okay. This all right. This isn't a command. This is the statement. The data structure may not contain number, so then nothing is. So it's like you gotta if you got an array of 1, 2, 3, and then you're like delete 4, is nothing's gonna be deleted. Let's say. Okay, pretty obvious. So we got an array with an empty array. Got an array. We got numbers that we can add and delete. This is easy so far. I totally could have done this. I wasn't even. It's just a lot of words, I think. Then a boolean has frequency, int frequency. Returns true if there is a number in the data structure that occurs frequency number of times. Otherwise, it returns false frequency. Okay, okay. So this seems a lot easier to me, man. I wish I did this one. um, I don't at least so far. So frequency frequent as far if I understand it correctly. Again, hey, don't. I'm an amateur boy. Don't. Okay. So frequency. Let's say. Let's use this boy. Let's just. Okay. All right. Frequency. So frequency. Someone inputs. Oh, I want frequency with number uh 2, and then our array has numbers. So we got those numbers in there. Yeah. Okay. So uh, I guess thinking about because we're dealing with array, deleting stuff is going to be hard. But anyways, back to this. So input. Oh, is there a frequency of 2? So basically, looks is there a number that occurs twice? So there's 1 4. There's 2 4s. Well, there's a 2 7. So yeah, yeah, there is. Yeah. Um. So yeah. So that's that. So this would return true. And what about frequency 1? Yeah, there's a 5. 5 only appears once. 8. Then 3. Well, 4 does note twice. 7 twice. No. No, there is no number that occurs only 3 times. So this is okay. Think about the logistics. It might be a bit tricky. So um, frequency tracker, add has frequency. Oh, so this is right. Create frequency tracker, add 3 has frequency 2. It's true because it has 2 3. Right. So explanations. Right. Yeah. Okay. So this is creates new frequency tracker. Easy. Adds 3, has frequency 2, and yeah. So yeah, it appears I understand it correctly. Okay. Then Then okay, so then it adds a one, deletes a one, has a frequency of one, uh, adds one, delete one, so adds a one. Oh, I see. Duh. Yeah, it's empty, so it's zero. So it's uh is false. Okay, right. That checks out. Then uh has frequency. Okay, so I think yeah, you get it. I get it. You get it. So then, all right. So just some quick brainstorming. This one's definitely tricky because the issue is adding. Okay, adding adding's easy, I think, but deleting is always with arrays. It's always tricky, and I'm not gonna get into that tonight. Like that would be hard to figure out for sure that that would cause me trouble. But it's just a boring normal problem that you always have to deal with arrays. So I'm not gonna get into that. Frequency, that's where the trouble. That's a tricky one because it's like because you got a bunch of different numbers and all of them could have the right frequency. Um, so um well okay, let's look at there's always constraints and frequent numbers. See, this is 10 to the fifth power. That's one with five zeros behind it. So that's 10,000, right? No, 100,000. Uh, at most, 2 times 10 to the fifth calls will be made to add. So so the issue is with this, there is a brute force way to do it. So an easy way to do it, to think about but it would be long. So you could have an array, just an array that would have to be 100,000. So it's a list with a length of freaking 100. Did I do that right? One, two, three, four, five. That big, 100,000 long. That's how big it is. Um, so you have a list of that. Uh, sorry. And then, so then, the, right. So then, and you just remember that a way to make, so then zero equals, and then zero equals one, uh, zero equals one, one equals two. What does that mean? So what does that mean? So that this would be, so you start at zero, you do a for loop, start at zero, but you increase zero to one for that loop, or maybe you just start at one. I don't know. I'm just trying to think. Maybe it'd be easier just because here's the thing, because the index so starts at zero, ends at one below the length. So you start at one, and then you check how many times has one appeared in the array, and then you count it, increase, and then you put that in the index for the one, which is zero. Or you can just start at one. You can ignore zero. That might be easier, which is why I put that one there. And then you can start at that. It doesn't really matter. So yeah, it doesn't matter. It doesn't matter. So you check how many ones, check how many twos, keep going till you get to the 100,000. Um, because it could equal that. There could be that number in there. And you have all the frequencies. So you have the frequencies of the numbers. Then you check if there's ever a frequency that equals the desired frequency, right? So If you want, is there a frequency of 4? Does the number, then it checks if there's a number that did appear 4 times. Again, I hope you understand that. That's I don't know how well I explain things. Um, so yeah, but see the issue with that is a lot. That's going through a lot of numbers. Now that's 100,000 in context. I don't think it's that big. I think computers still zip through that. Why don't we check? Why don't we give a little checkaroonie? Um, so let's do Control C, Control V, and then, by the way, I should be faster at typing than I am because I I'm just not good at typing. So 1, 2, 3, 4, 5 can even okay can deal with numbers that big. Then uh system dot let's just have it be print, and we will print I I guess doesn't matter. Plus give it a space. Yeah. So zip, yep, looks pretty fast. So then a good way to test. Um, hold on. So let's switch it back to print line. I think a good way to test this is to do. Let's just okay. So this is just to create for int j equals 0, while j is less than 1, 2, 3, 4, 5. J plus plus. That is what my brain goes through each time I write a for loop. So then we write out system.print. Let's keep it at print. Um, J plus. Yeah. Okay. Nope. Not inside of it. Thank you. Okay. Print system. Oh, we need an out. We need out, boy. Out. White. Out. Um, then run that. Oh, okay. So it's running. So this is slow. This is like, as you can see, it's going slow. Oh, my fans are turning on. Is it even doing it? What's going on? Okay, hold on. The first number, right? It should print out. Oh boy. Um, First number should be 0, then 1, 2, 3, going down. Let's stop. Let's see what happens when I stop. Oh boy, 2 lines of code have been printed out. I don't understand. One line. So you can do one. You can do one line. Ah, yeah, okay. I don't understand that. You can do one line immediately, but 2 lines. 250. I don't get the issue there. Um, does it reset? It shouldn't. It should. I don't know. 999 365. Yeah, wait. Oh yeah, look at that. Look at that. 365. Why isn't it print line? So it should print out one and then go. It should go to the next line. It's not exactly perfect. But anyways, yeah, that takes forever. So if you do it 100,000 times 100,000. So what I'm trying to say is it can be slow. Now, that is just how I thought about it off the top of my head. So I don't know. I don't think it would ever like multiply within itself like that. I don't think that would ever be an issue, but it's always sketchy to do a for loop that's 100,000 big. but that's one way to do it. I'm probably are already on this too long. So let's go to the next problem. Okay, number of adjacent elements with the same color. There's a zero index array, nums of length n. Initially, all arrays elements are uncolored, has a value of 0. Okay, okay, this is simple so far. 2D integer array queries, where queries I equals index. Oh boy, oh boy! I just realized a 2D array. Um, index I color I for each. Okay, so maybe it won't be too bad. For each query, you color the index I with the color I in the nums array. Return an array answer with the length same length as queries, where answer I is the number of adjacent elements with the same color after the query ith. So um adjacent elements. Oh boy. Oh man. Oh man. So they are colored. I don't know, man. Oh boy. Hmm. Yeah, this one. I'm sorry, guys. This is too much for my brain. I can't even begin. Let's look at the next one. Maybe I'll get it. Maybe I won't. These are the hard ones. So you got a perfect binary tree. Okay. See, this one so I learned about binary trees in my class a little bit. So I was like, oh, maybe I could do this one. I could do this. Um, and so, okay, yeah, this is helpful. This is nice. A perfect binary tree where each node, except the leaf nodes, have exactly two children. So, yep, it's exactly symmetrical. That the only ones who don't have children are the end nodes at the end boy here's, and they don't have any nodes. But everybody else has two nodes. One has two nodes, two has two nodes, three has two nodes. Oh, I think I'm okay. So we got this tree, and it's holding. Okay, so all right, and sorry, I didn't read this. Um, so you're trying to find the cost if you go down to a node, how much is going to cost. Return the minimum number of increments you need to make the cost of pass to each leaf node equal. See, I don't know what this means. I thought I understood it, but I don't. I'm sorry, guys. Okay, I think it's showing my noobishness right now. Um, we did the easier. I did the one of the easier ones, and I pretty sure I know a way I could do this one, a slow way of doing this one. So, this is my first episode. Hopefully, I get better at this. I don't know how much better over the summer and get. Maybe this will make me get better. Um, my real goal over the summer is just it's like weight training, just keeping my. This is like not making my muscles stronger, just enough to make sure my muscles don't get weaker. Right? That's what I'm doing over the summer. Um, but maybe this first one definitely did push me a little bit. It's not with learning new coding stuff, I guess. It's just thinking of the logic. It was a bit trickier. Like is what the real struggle was. So maybe this will help me get better. Just working my code out a little bit. Maybe um you know what? Okay. John, is there a way? Okay, let's see if I can look at this man's code. Can I make this bigger? No. Okay. Difference array. Oh, he uses vectors. I don't know what that means. Memset. Oh man. Size of B. I think it's the same idea though. Let's see. What about on a stack? How did he do? Can I understand his? Oh, good. So yeah, I saw a meme about this in the comments. Um, did it in like one line. You didn't have to do that, buddy. Although, yeah, okay. How? How? 2 minutes? 1 minute? So, what if we like we go down a bit? I just want to look at the code. Let's see. Who is our lucky dude? Someone. Let's try. Let's get someone who like looks like they took a reasonable amount of time. This is what I did to try and find how far down I was. See if anyone did worse than me. Um. So okay. So yeah, this is no. I don't understand what these times mean. Maybe he had them all open at the same time. I don't know. Hmm. So I just wanted to look, see if maybe I could learn something. See, but if you know, looking at someone else's code is there's always a little bit like it's hard to know what's what, and sometimes just deciphering what something says is the hard part. So I don't know. I might at some point do it, but that sounds like a lot of effort. But yeah, okay. So I hope you guys enjoyed. Um, I think I'll go. I think so. Let's go contest. The next. Ooh, okay. Hmm. Okay, so I don't. All right. Okay, there's bi-weekly. They're at the same time. Oh, not exactly. Same day. Um. So I guess I'll do both. Maybe we'll see. We'll see. Um. So this one starts at 10:30. Oh, they. Oh, this one. Oh. I don't. This one starts at 10:30 at night. Like, oh yeah, coding people. That okay? That's chill. Yeah, people code late. We're nerds and we're all up late. But then this one's at 10:30 in the morning. Um. So let's look at this. Does it say how much time it is? How much time we have? The uh, blah blah blah. I just want to know if it's still 1.5 hours. I don't know. So, but definitely next week I'll do at least one of these. Probably just weekly contests because I don't know if 'cause even see here's the thing. Even if I can convince myself to get up at 10:30, how the frick am I gonna my brain gonna work fast enough to like do the do the problems? So I guess we'll see. But yeah, I'll definitely have something done. Because as you can see, I'm already up at 1:26 in the morning. Uh, so I'm a night owl for sure. But I hope if you are still watching, you are an absolute unit. Um, you are the coolest, and I hope you enjoyed the video. Thank you for watching. Have a lovely day.